Hello everyone, welcome back to the channel where we break down math concepts to make them easier and more fun to understand. In today's video, we're diving into super important topic and that is measures of dispersion. So what is dispersion? Now, you might be asking what exactly is dispersion? Why does it matter? Well, measures of dispersions helps us to understand how spread out or clustered the data is. Whether you're working with test scores, survey results, or even sports stats, dispersion can tell you a lot more than just the average. So stick around because by the end of this video, you will know about range, variance, standard deviations, and more. And trust me, understanding these concepts will give you a huge edge in data analysis and problem solving. Ready? So let's get started. As we said, dispersion is described the amount of variability or spread in a set of data. The most common measures of dispersions are the range, the variance, and the standard deviations. So by these three common measures, in terms of measures of dispersion, let's start with the range. Range is the difference between the largest and smallest data in a given data set. It is defined through the formula which is R is equal to highest minus the lowest value. So the thing that you are going to look here is just the largest data and the smallest data. So now take a look for the given example. A grade 11 teacher administered a 20-item test to his 10 students in mathematics. The result of the test are gathered. We have 18, 19, 20, 17, 18, 11, 15, 16, 19, and then 20. And we are going to find the range. For us to find the range, that is the highest score minus the lowest score. So look for the highest score in this given data. So that is 20. How about the lowest score? So that is 11. So using the concept of range, that is the highest score minus the lowest score. So that is 20 minus 11. So that is equal to 9. So therefore, the range of this data is equal to 9. Simply as that, that is the range for the ungrouped data. So now let us take a look with the variance. Variance, it is the average square deviations from the population's mean. Okay, so we need to consider two formulas in terms of variance. We have the variance of the populations and we have the variance of the sample for their formula. We use the formula for population variance when you have the data for the entire populations. In this case, every single member of the group you're studying is represented in your data. Since there's no need to account for missing data or variability within the population, the formula divides by n. So the total number of our data points. Then we use sample variance when when you only have a subset or a sample of the entire population. So in this case, the formula divides by n minus 1, where n is the sample size, instead of n because the sample size is used to estimate the population, and dividing by n minus 1 compensates for the bias that would arise if you only use the sample data. So what are the key considerations here? If your data set represents the entire populations, use population's variance. If your data set is sampled from the population, use sample variance to adjust for the sampling error. So in practice, most of the time you will use sample variance because it's rare to have data for the entire populations. Okay, so like for example here, we have an ungrouped data. A fourth-year student score in a quiz 18, 19, 20, 17, 18, 11, 15, 16, 19, and then 20. So by those data, because this is ungrouped data, and we are looking for the sample variance. So by this given data, let us have a table and looking for the sample variance. These are the formula, which is summation of the square of the quantity x minus mean all over n minus 1. So as we can see, we need the value for the mean in our formula. So let us take a look for getting the mean. So that is the summation of x over n. So our x here, that is the data values that we have here in our given problem. So that is 18, 19, 20, and so on. And getting the sum of that, that is equal to 173 and divided by 10. So 10 is the total number of our data values. As you can see, we have 173 divided by 10, that is equal to 17.3. So that is our mean of this data. Okay, so we are going to rewrite that into our second column. So now we are down into third column. So that is our x minus the mean. So x minus mean, on the first row, we have 18 minus 17.3. So that is equal to 0.7. Down on the second row, that is 19 minus 17.3. That is equal to 1.7. So 20 minus 17.3, that is equal to 2.7. So we have 17 minus 17.3, that is equal to negative 0.3. As you can see, we are going to have the x minus the mean. And you are going to do that until you meet the bottom part. So we got 0.7, 1.7, 2.7, and so on. We are going to rewrite that into our third column. So now, because we have already our given value for the x minus mean, now let's take a look with the square of the quantity x minus mean. So we are going to take 0.7 times 0.7. Okay, so that is equal to 0.49. So the same thing we are going to do with second row, 1.7 times 1.7. So that is equal to 2.89. The same thing, 2.7 multiplied by 2.7, that is equal to 7.29. You will do the same thing until you meet the bottom part. Okay, now, so rewrite it at the fourth column. So now we already have the square of the quantity x minus mean. So we are going to get the sum of our fourth column. So added by 0.49 plus 2.89 plus 7.29 and so on. That is equal to 68.1. Okay, after that, because we've already the summation of the square of the quantity x minus mean, which is 68.1, let us apply the formula and this given. So our n, that is the total number of data values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, our n is equal to 10, which is that is the total number of data values that we have. So now we are going to apply the formula. So we've gathered earlier that's summation of the square of the quantity x minus mean, that is equal to 68.1. Our n is 10. So let us simplify this equation. So we have 68.1 divided by 9, that is equal to 7.57. So therefore, the sample variance of this given ungrouped data is equal to 7.57. Okay, now let us take a look with the standard deviations. So standard deviations is the most common used indicator of the degree of dispersion and is also the most dependable measure to estimate the variability in a total populations. So in the low standard deviations means the data points are close to the mean, indicating less variability or the spread in the data. When we have a high standard deviation, it means that the data points are spread out over a larger range, showing greater variability. So why standard deviation is important? It helps to understand the consistency of the data. For example, in a set of exam scores, a low standard deviations indicates that most students scored similarly, whereas a high standard deviation suggests a wider range of performance. So in finance, the standard deviation can indicate the risk or volatility of the investments. So a higher standard deviation suggests more unpredictable returns. So now let us consider the two formulas, the same thing for getting the variance. So we have the population standard deviations and we also have the standard of the sample. Okay, let's take a look by this given example. As we have earlier, we have the same value for the ungrouped data given. So earlier, we've got the value of the sample variance, which is equal to 7.57. But as you can see, the formula for the standard deviation is also the same thing for our sample variance, which is just take the square root of your sample variance, you will get your sample standard deviations. So now our sample variance is equal to 7.57. So take the square root of that, that is equal to 2.75. So therefore, the standard deviations of this given ungrouped data is equal to 2.75. So that is for the ungrouped data. So now let us take a look with the group data. So we are going to determine the range, the sample variance, and the standard deviations of the given data below. So how are we going to get the range of our group data? So for us to get the range, that is the upper boundary minus the lower boundary. For us to get the upper boundary, that is equal to upper limits plus 0.5. So for us to look for the upper limits, that is the highest limits in our given data. So that is 80. So 80 is the upper limits plus 0.5. That is equal to 80.5. And that will be our upper boundary. Now let us take a look with the lower boundary. That is lower limits minus 0.5. From now on, we are going to look for the lower limits, which is the lowest limits in our given. So that is 18. So 18 minus 0.5, that is equal to 17.5. So now we already have the upper boundary and the lower boundary substitute into our formula. 80.5 minus 17.5, that is equal to 63. So therefore, the range of this data is equal to 63. Now, let us take a look for the sample variance. Okay, so as we have a given data, because this is a group data, we need the value of the product of the frequency and the midpoint, which is for getting the mean. Because in getting the sample variance of a group data, that is the summation of f multiplied by the square of the quantity x minus mean all over n minus 1. And for the formula for getting the mean, that is summation of f of x over n. But before that, let's take a look for the midpoint. We need that for us to get the value of mean. So for us to get the midpoint, that is x is equal to upper limits plus the lower limits divided by 2. Okay, let's take a look for the first row. So for us to get the upper limits, what is the highest limits in the first row? So that is 26. So the lower limits, that is 18. So now, for the value on the first row, that is 26 plus 18 divided by 2, that is equal to 44 divided by 2, we have 22, which is on the first row, the midpoint of our given, that is equal to 22. We write that on the first row. So now let's take a look on the second row. So we have 35 for the upper limits and we have the lower limits, which is 27. So get the sum of that, that is equal to 62. And now divided by 2, we have 31. So 31 is the midpoint of the second row. So you will do the same thing until you meet the bottom part. Okay, so now we have the midpoint, which is 22, 31, 40, 49, 58, 67, and then 76. Now we are going to get the product of the frequency and the midpoint. We will multiply On the first row, that is 3 multiplied by 22, that is equal to 66. Okay? So now we have 5 multiplied by 31, that is 155. So 9 multiplied by 40, that is equal to 360. And so on and so forth. You will do the same thing until you meet the bottom part. Okay? So rewrite that on our fourth column, that is the product of frequency and the midpoint. So now we already have the value for the frequency and the midpoint. So let us take the sum of that value. So now we have 66 plus 155 plus 360 plus 686 and so on. That is equal to 2,459. For us to get the value n, that is the total number of our frequency, and that is equal to 50. Now let us just substitute that value into our formula for us to get the value of mean. So 2,459 divided by 50. Okay, so that is equal to 49.80. So now let us rewrite that into our fifth column, which is the value of mean of this group data. Okay, so now we already have the value of x, which is the midpoint, and the value of mean. So let us just take the x minus mean. So 22 minus 49.18, that is equal to negative 27.18. So you will do the same thing. 31 minus 49.18, that is equal to 18.18. So 40 minus 49.18, that is equal to negative 9.18. So you will do the same thing until you meet the bottom part. Okay, so because we already have the value for x minus mean, let us take the square of our x minus mean. So negative 27.18 multiplied to negative 27.18, that is equal to 738.75. Okay, you will do the same thing. Take the square of negative 18.18, that is equal to 330.51. And on the third row, you will do the same thing. That is negative 9.18 multiplied negative 9.18. So that is equal to 84.27. And you will do the same thing until you meet the bottom part. So now, let us have with the frequency times the square of the quantity x minus mean, which is that is our needed in our formula, which is what is our frequency on the first row, that is 3 multiplied by 738.75. So that is equal to 2,216.25. So on the second row, the frequency is 5 multiplied to 330.51. So that is equal to 1,652.55. And the same thing, you will do that until you meet the bottom part. So now let us get the sum of this value. Okay, so 2,216.25 plus 1,652.55 plus 758.43 and so on, that is equal to 8,827.26. Okay, so now we already have that value. So let us just substitute those values that we've gathered. So our numerator is 8,827.26 divided by 50 minus 1. And that is equal to our denominator, that will be 49. So simplify this, that is equal to 180.15. So therefore, the sample variance of this group data is equal to 180.15. So now, we've got earlier the value of the range, that is equal to 63, and our sample variance is equal to 180.15. As we said earlier, just take the square root of your sample variance. You will get the standard deviation sample. Okay, so 180.15, that is our sample variance. So take the square root of that. That is equal to 13.5. 42. So therefore, the standard deviations of this given is equal to 13.42. So thanks for watching for this SuperMath video on measures of dispersions. If you found it helpful, don't forget to hit the like button and subscribe for math tips and tutorial. Got questions or need more clarification? Leave a comment below. I'm here to help. Check out the other videos on SuperMath for more insights into data analysis and much more. Keep practicing, stay sharp, and I'll see you on the next lesson. Bye for now.